All right, so this is part two of our Algebra 1 review number one. We're going to be solving systems of equations, so just kind of some definitional stuff here to get things started. A system of equations is a set of two or more equations that share variables. When we have as many equations as we have variables, then we may be able to solve for the variables. So actually find values that are solutions. We're going to be looking at two variable linear systems. So just to kind of make sure we're all aware of what we're talking about, a system of equations, again, is a set of multiple equations. So we're going to be looking at two variable systems. So we will have a group of equations like this, like 2x minus 3y equals 4, and y equals 6x minus 10. So something like this is a two variable, two equation system. We have variables x and y, x and y. We'll talk about techniques for solving this right now. This equation is in what we call standard form. This is an equation of a line in slope-intercept form. Since we have two equations and two variables, as many equations as variables, so that's true, we can solve this. All right, a few techniques for solving. So one of them is graphing. So if you can graph both of the equations, so we're going to be looking at linear equations. So our graphs are going to be lines. We'll be graphing both lines, and we're going to figure out where they cross. So we graph the lines. That's line 1, graph line 2, right? And then right here, this is our solution. The x solution, comma y solution is the point where those two lines cross, and there we go. That's the first way to do it. Second way is a method called substitution. This one's going to be very useful and probably the most applicable to other types of systems of equations that are not necessarily just lines. Substitution is going to be a really, really popular technique. So is graphing, but as far as an algebraic technique, substitution is probably the most applicable for the future. And then our third method here is called elimination. So there's a few specific times where we're going to use elimination. Elimination is when we take our two equations and we either add them together or subtract them from each other to create a single equation. And in doing so, we eliminate, get rid of, cancel out one of the variables so that we now, instead of having two variable equation, we have a one variable equation that we can solve. Now, this one is kind of can be kind of tricky depending on what type of equations that we start with. For elimination, we're mostly going to be looking at equations that are in standard form. If we have both equations in standard form, that's going to be most of the time when we use elimination. All right. So the solution to a system of linear equations, we have a couple options. There could be one solution. So one solution is when one solution is when the two lines intersect at a singular point. That point, which is right down here, -2, -2, that is our single solution. This is going to be the most common. We find one solution. There are some other options, though. We could have a system where there is no solution. The reason being, those two lines that are created in our system of equations here are actually parallel lines. Parallel lines will never cross. Therefore, there is no point that lies on both lines, so no solution to our system. And then the other option is we could have a system of equation that has an infinite number of solutions. And the reason for that is because the lines are actually the same. They are different forms of the same linear equation, and therefore any point on those lines would be a solution to the system, and there's an infinite number of points on our line. So those are kind of the three types. Again, most commonly, we're going to be dealing with one solution, but we do need to be able to recognize that it's possible that there's a no solution system or an infinite solution system. All right. Here's an example of a system of equations. So we have our first equation, y equals 3x plus 2, x minus y equals 6. Remember, these do have coefficients of a 1 there that may be useful for us when we're doing that. So here's our system. Sometimes I write these little brackets around them just to know that these go together. We're talking about a system of equations, or you may see that. It's not necessary, though. So we're going to be using the substitution method. And the reason we're going to be using substitution is because one of our equations is in a form that is already solved for one of our variables, meaning in this case, y. So we have an equation that is solved for y. It's great, because what that means is I can substitute, I can replace y with 3x plus 2 anywhere I want. And where I want to do it is into the other equation. I can put the expression that y is equal to, 3x plus 2, into this equation because y is equal to that. And so let's take a look at what that substitution looks like. So it becomes x minus, and then instead of y, we're going to replace it with what y is equal to based on the other equation. Equals 6. Remember, this chunk right here in our original equation was just y. But since our first equation tells us that y is equal to this expression in terms of x, I can make a substitution. And that gives us now an equation that has only x in it, and we can solve it. Do notice here that I did put some parentheses around that, and in this case it's very important. Since I'm subtracting y, I need to be subtracting this whole quantity. If I didn't put parentheses around this, I would get a slight, I probably would not be correct here, because I need to be subtracting this thing, so I'm actually going to be distributing that subtraction when I go to solve it. So whenever you're making substitutions, I certainly recommend putting parentheses around the expression that you're substituting in to avoid particularly this mistake. All right, now let's do that a little bit. Distribute that negative. That's minus 3x minus 2 now equals 6. And then it becomes a matter of combining like terms. So I have 1x minus 3x. It's going to be negative 2x minus 2 equals 6. And put these two terms together to get that. And then we need to start solving. So we need to get rid of this minus 2 by adding 2 to both sides. And we get negative 2x equals 8. And then divide both sides by negative 2. 8 divided by negative 2 is negative 4. All right. Here's where a lot of people stop. They'll just go ahead and just be like, all right, I'm done. I found a solution. And when we were solving one variable equations, that was great. But for a system of equations, we need two solutions. We need one for each variable, for x and for y. We have solved for x. X is negative 4. Now we need to solve for y. So now what we need to do is take this value of x that we know x is equal to and substitute that into one of these equations. You actually get your choice. You should be able to get the same answer regardless of which one you do. For me, the first equation looks much easier. So that's what I'm going to do. I'm going to substitute into that equation for x. So it's going to become 3 times negative 4 plus 2. Right? That used to be an x. Now it's negative 4. This just becomes more or less a calculation for us, right? We're doing 3 times negative 4 is negative 12 plus 2. Negative 12 plus 2 is negative 10. So negative 10. That is our solution for y. We've solved for both variables. And these two lines will intersect each other at this point, negative 4 comma negative 10. That's it. And a lot of times you will see the solution represented this way, represented as a coordinate point of the intersection. Other times you will just see it written out as x is equal to negative 4, y is equal to negative 10. It doesn't matter. They're both fine, both valid. All right. And here's a graphical solution here. I used desmos.com to graph both of those equations, and awesome. That was the point that we found, so good to go. All right, here is another example, and we're going to try to use substitution once again. So again, substitution. What I want you to notice this time is that neither of my equations is solved for one of the variables. I don't have an equation that says x equals something or y equals something. So in that case, I need to do a little work. I need to pick one of these equations and solve it for one of the variables. Doesn't matter which one. I can go either way. I could solve for y, I could solve for x. I kind of want to just do whatever looks easiest in either equation. So I have to do, you know, some deciding here to figure out which one. So when I'm looking at it, if I think about maybe solving for x in the second one, right, I would have to move this over, divide everything by 3. That certainly looks possible, right? I could do that. But on this first equation, actually looks a lot easier. If I want to just solve for x, all I got to do is get rid of that 2y. All I got to do is just move that 2y to the other side. And that seems to be the easiest. So that's what I'm going to do. I'm going to take that first equation, and I'm going to solve this for x. I'm going to get rid of this minus, I'm going to get rid of this plus 2y. So I'm going to subtract 2y on both sides. Okay, so I get x is equal to, and then I can sort of write this however I want. I could do -10 minus 2y. I could do minus 2y minus 10. As long as I keep the proper sign in front of each of these terms, they're both negative, so they'll both have a negative in front of it. All right, now we have this equation. This equation is equivalent to this first one, meaning it would represent the exact same line. All the solutions to them would be the same. They're more or less the same, just in different forms. So now I know that x is equal to this. That means that anywhere I have an x, I can substitute this for it. And that's what I'm going to do. I'm going to do it into the other equation. So where I have an x here, I'm going to replace it with -2y minus 10. So I'm going to take this equation, and I'm going to make that substitution into it. So instead of 3x, I'm going to have 3 open parentheses. That's where I'm going to put my substitution. Minus 6y equals -6. So right here, where the x was, I'm going to put minus 2y minus 10. Now we've made the substitution, right? We said that x was equal to this, so we replaced x with it, and we've actually done the substitution step. Now it's a matter of solving this equation. This equation now only has y as a variable in it, so we can solve and figure out a number for y. So distribute. We have this coefficient out in front that's multiplied, so we need to distribute that. That becomes -6y minus 30 minus 6y equals -6. I'm going to combine like terms here. So I have -6y and -6y. That's going to be -12y minus 30. Now I need to start solving this. I need to get rid of the things on this side that are not my y. So I'm going to be adding 30. So I get -12y equals 24. And then divide both sides by -12. 24 divided by -12 is going to be -2. And we have one of the variables solved now. We have solved y is equal to -2. That's awesome. Now we need to figure out what x is equal to. So now I need to take this number, -2, and substitute it into y. I have my choice. I always like to go back to the original equations in this case. I could use this one as well. It would be fine. I mean, I do trust that I did this correctly, because if I didn't do this correctly, then the solution is not right. But I'm going to go back to the original, and I'm going to pick one of these. Doesn't matter which one. I should get the same solution either way. I'm going to pick the first one because it looks easier. There's more coefficients here. So I get x plus 2y, which is 2 times -2, 2y, equals -10. Okay, that becomes x. 2 times -2 is -4. And then I add 4 to both sides, and I get x is equal to -10 plus 4 is -6. So there we go. There's our solution for x, -6. We can leave it like that, or we could write our solution as a coordinate point, x first, so -6 comma -2. So these two lines, if we graph them, should intersect at this coordinate point. All right, let's go ahead and clear that, and then the next slide should check the solution. And that is what we got, -6 comma -2. This was one of the ways to use substitution to solve this problem. We could also have used another method, but I'm just showing substitution in this case. These both being in standard form, some people may have chosen another method like elimination or something else to solve them. And another way we could have also, instead of solving for x initially in this equation, we could have solved for x in this one, or we could have solved for y in either of them. So there's a lot of ways to have gotten this started. Some of them are easier than others. Some of them would be dealing with only whole numbers, or some of them we may introduce fractions or decimals, which can make things a little bit harder. And I tried to pick the easier way. So thinking about your process before you do it can be important, but there is more than one way to solve them, almost always. All right, so now we're going to be doing solving a system of equations using the process called elimination. Elimination is when we combine the equations together by adding them or subtracting them, and in that addition or subtraction, we actually are allowed to, we end up canceling out one of our variables, eliminating it, leaving us with just a single variable equation, which is easy to solve. All right, so just kind of taking a quick look at this one. Sometimes they're set up great and you go ahead and jump straight into it and you can just eliminate one of the variables right off. Really quick, before you do elimination, generally you want to do elimination when both of your equations are in what is called standard form. If they're in ax plus by equals c, these could be positive, negatives, could be plus, minus, but this general form elimination is something that you could consider. In this case, they are 6x plus 15y equals 3. Standard form, same here, standard form, minus is fine, doesn't matter, just means that we're dealing with a -2 as our b value. So they're both in standard form, great. That's one of the times we use elimination. But looking at this, if I just add these together, 6x plus 3x, that's 9x. That doesn't get rid of any x's, doesn't eliminate the x variable. 15y plus -2y, that again is 13y, doesn't eliminate the y. So just adding them together isn't going to do the trick. What we need to do is we need to figure out a way to multiply one of these equations by a constant, or maybe both of them sometimes, but in this case, just one of the equations by a constant, so that when we do add them together, something's going to cancel out. So what I need, and when I'm looking at it, I want to see, all right, is it easy for me to eliminate x or y? I'm going to be focusing on the x's for this problem, but sometimes we may focus on y. I want to make this 3x a number that will eliminate or cancel with that. So what I want to get is 6x plus, and I want this to be a -6x, because it happens when we add those together, 6x, -6x, we end up getting 0. Just gone. Those two things are opposites of each other. They cancel out. We eliminate the x variable. So what we need to do is multiply this equation by something so that we get a -6x here. That's easy enough. If we want to make this into a -6, we need to multiply by a -2. So I'm going to multiply the entire equation. Both sides distribute to everything, multiplying it by -2. So let's go ahead and go through that. We get -6x. -2 times -2y is going to be +4y. -2 times 11 is -22. Great. Now I'm going to go ahead and rewrite this one over here. Be very careful when you're rewriting your equations to copy them out accurately. There's a tendency to make small mistakes here, leave off a positive or a negative, or change a number or something, and you'll get the wrong answer. So got to be careful that you copy things down correctly. All right. Now we're going to add these together, and we get, this is what we're looking for, 6x plus, we're going to add them together, plus -6x, that becomes 0 right here. This becomes 0. We have eliminated the x variable, and we're going to have only y left. So now 15y plus 4y is 19y equals, that's where our equal sign is, and then 3 plus -22 is -19. Awesome. Now we have a very simple equation with just y in it. We can solve for y. Divide by 19, divide by 19. We get y is equal to -1. So that's our first part of our solution. That's the y coordinate solution. Now we need to solve for x. So we're going to substitute this number, -1, into either of these equations, doesn't matter. Whatever, I'm just gonna pick the second one. You could pick either one. So 3x minus 2 times -1 equals 11. Multiply that out, that becomes +2. So I have 3x plus 2 equals 11. And now I need to solve this. Subtract 2. We get 3x equals 9. Divide by 3. 9 divided by 3 is 3. So that is our solution for x. So we can write our solution as a coordinate point, as an ordered pair, 3, -1. These two lines, these two linear equations, will intersect at the point 3, -1. Awesome, graphically checked. That is the intersection point, 3, -1. You can always use Desmos to kind of help check, but I do want you to make sure that you solve these equations using the algebra. The algebra is important. All right. Now, this one's going to be a little bit harder, but we're still going to use elimination. Sorry, still going to use elimination. Okay, let's go ahead and go through it. So remember, we can try to eliminate x or we can try to eliminate y. It is up to us. Looking at it, I have 2x and 3x. It's going to be difficult for me to turn this 2 into a -3 so that when I add these, they go away. Similarly, I have 3y and 4y. It's going to be difficult for me to turn this 3 into a -4, right? I'm not going to be able to multiply by any whole numbers and make that happen. So this is one of these situations where I actually need to change both equations. I need to multiply both equations by a constant. And when I do that, I kind of have a choice. It doesn't really matter which one I change if I'm trying to go for eliminating the x's or eliminating the y's. So you could do this either way. In this problem, I'm going to eliminate the y's just as a different process from last time. So I want these to end up being the same number, right? Like 8 and 8, but one of them needs to be positive, one of them needs to be a negative, so that they'll cancel out and become 0, eliminate. In here, multiplying by a constant, what can I make these the same? I want to look for the least common multiple between 3 and 4. Well, 3 has multiples of 3, 6, 9, and 12. And 4 has multiples of 4, 8, 12. Well, 12 is the lowest common multiple for these. I can turn both of these into 12. I'll want to turn one of them into a -12, so I'll keep that in mind. So let's make this one 12. So that means multiplying by 4. That's going to give me 12y here. Let's go ahead and go through that process. 4 times 2x is 8x. 4 times 3y is 12y. And 4 times -1 is -4. Remember to multiply everything by that number. Distribute it to all parts. Okay, and now we want to turn this one not into 12, we want to turn it into -12. So we need to multiply this one by a negative, right, to make this negative. And 4 times 3 is going to give us 12. So we're multiplying by -3. -3 times 3x is going to be -9x. -3 times 4 is going to be -12y. Now we have what we wanted. We have 12y, -12y. Those are going to cancel when we add them together. And then -3 times -4 is actually +12. All right, now we can add these together, and we already know these are going to eliminate because we have a +12y and a -12y. Those are going to make 0. Our y's are going to cancel out. But we need to get the rest of this here. So 8x plus -9, that's going to be -1x. -4 plus 12 is 8. Divide both sides by -1. I'm going to get x equals -8. That's my first solution. My next solution, I need to substitute -8 into either of these equations. Again, doesn't matter which one. I should get the same solution. In fact, you could check and do both. I'm going to use the first one. So I'm going to substitute -8 right here. So 2 times -8 plus 3y equals -1. When I'm doing this substitution, I always go back to the original, one of the original equations. So multiply this out, -16 plus 3y equals -1. I'm going to add 16 to both sides to get rid of that. I get 3y equals 15, -1 plus 16, and then divide both sides by 3. 15 divided by 3 is 5. So y is equal to 5. And our solution, the ordered pair that represents our solution, the point where these lines intersect is -8, 5. X first, y second. Again, I could have substituted that number into the other equation. I should end up with the same solution, but you could check that if you want. Let's go ahead and make sure our solution is good by taking a peek at the next slide. Lines cross, yes, -8, 5. That is the solution to this system.